Glass has been a part of the human life for thousands of years. We use it in everything, from windows, glasses, buildings, and even artwork. But here's the weird thing. Glass isn't what people think it is. It's something much stranger. It looks like a solid, it feels like a solid, but scientifically, it's an amorphous solid. In this video, we're breaking down one of the biggest misconceptions in everyday science. Why glass doesn't fit neatly into the usual categories of matter, what it actually is, and how it changes the way we think about the materials around us. And by the end, you'll never look out a window the same again. Let's start with what we learned in school, the states of matter. Gas, liquid, solid. Simple, right? Solids have a fixed shape and volume. Atoms are tightly packed into a repeating pattern. Liquid has a fixed volume, but no shape. They flow. And gases have neither, not a fixed shape or a volume. So where does glass fit in? It looks like a solid, it doesn't pour, and it doesn't change shape unless you really force it to. Actually what scientists call an amorphous solid. Amorphous means without shape, or more precisely, without crystalline structure. In a crystalline structure, atoms repeat perfectly, kind of like walls. In glass, atoms are just jumbled and disordered, more like frozen spaghetti. So even though glass looks like a solid, its internal structure just looks more like a liquid that's not moving. This strange middle ground state is sometimes called a supercooled liquid, but that term's a little misleading. It's not exactly a liquid, and it's not technically a solid because it holds its shape, but it's not a true crystalline solid like salt or diamond. Now here's where we get to the fun. There's a common myth that olden glass windows were thicker on the bottom because glass flowed downwards over centuries, like honey, but in ultra slow motion. Is that true? Scientists say that's not true. It's a common myth. The real reason? Old glass-making techniques weren't very precise. When they made glass panes, they were usually uneven. Builders just kind of put the thicker part at the bottom for stability. The myth exists for a reason. Glass can technically flow, just not on human timescales. We're talking billions of years. At room temperature, the atoms are mostly still, but not entirely frozen. In fact, scientists have measured the reaction time of silica glass. It's about 10 to the 32 power. For a little reference, that's the entire lifespan of the universe. So yes, your window is flowing, but at a speed so slow that it might as well be frozen in time. Now, the next time you look out your window or tap your phone, you're not touching some boring everyday material. You're looking at something that doesn't even fit the categories we use to define matter. It's not a solid in the usual sense, and it's not a liquid either. It's a frozen mess that somehow stays together. Glass is a paradox. It's clear but confusing, strong but fragile, ancient but still interesting. Tap the video on screen to learn the next science mystery that you never learned in school.